So we have an A1990. It says it's dead. I'm not sure if you guys can see that. Is the lighting enough? Okay. Try to move this a little closer, move this a little out. Okay. So it says it's dead. As usual, the first thing we do is we will not connect our charger until we can ascertain what state the device is in. I keep stressing this whenever you're working on these devices. It's important before you introduce power to the device to know what state the device is in. So first and first, we want to define the state of the device before we can run power to it. And also, when you are opening these devices, be very much aware of the touch bar so you don't crack it. Be careful with the amount of pressure you place on the machine so you don't crack the touch bar. Okay, so looks like there's been an attempted repair on this one. We're not sure. Okay, so we see that the battery data cable has been partially, the connector for the battery data cable has been lifted, which means somebody was definitely here before. And we can see this screw is missing. We have this screw missing, we have that screw missing, we have that screw missing. So two things here, it is either this was someone trying to fix it, or this could be from a previous repair and the screws were not completely put back. But then this wouldn't be the case because this being lifted simply means, I mean, if this was from a previous repair, you might have issues of the battery not being detected. So definitely this is not going to be an issue from a previous repair. Most likely somebody tried to fix it and then they couldn't get it fixed, and then yeah. In any case, because this is an A1990, the first thing we want to do is we want to check to see if it's one of the commonest issue, or one of the commonest failure, which is that results from C9081, which will create a short on the PPBUS rail, and by extension may also affect the NAND chip because of U9080, a buck converter that's supposed to take 12.6 volt and then even out and switch it, break it down to 2.5 volt for the NAND. So the first thing we want to do is we want to disconnect the battery data cable and then confirm if we have a short on our PPBUS line. So to do that, we put on our multimeter, we switch to continuity mode. First, we put it together just to be sure. Okay, now the next thing I want to do is I want to place one probe on ground. Now any of this metallic can be used as your ground. So we want to place one probe on ground, and then when in continuity mode, it doesn't matter what is placed on ground. You can place the red probe on ground, the black, it doesn't matter. So we'll place the black probe on ground and then the red probe. Let's see, and we have a short. Now something else I also want to mention. So because you see that it's 0035, that is not good because so 0035, it's an indication that the short is not completely the short, it's not completely on the main rail which we are measuring now. You see so if we had 001, for example, that is something that we would like to work with. But 003, it's a very scary one. That it's very much looking like the land may have been affected, but that we can confirm. Sometimes it may also be that the battery of the multimeter is dying, but we just hope that that is not the case. So one way to confirm that is to take out the board, and then we can find out. Yes, we definitely do have a short on the board, but then what we want to confirm is where the short is, coming from. So we want to take out the screws. First, we're using a T5, and then we will use a T4. So you can, so first and first, the screws for the T5s are out. Then we will grab a T4. For some screwdriver set, your T4 will be almost, you can use your T3 in place of your T4 for some screwdriver sets. Okay, let's quickly take out the board and let's enable another T5 screw. Let's really hope that the issue is contained on the PPBUS. No NAND has been affected in the process. Because if you 9080 fails, then it's going to take whatever voltage it got from PPBUS and sent to the NAND. That would be bad. Now that's going to be an expensive repair, and also that is going to mean that the client will not be able to have access to their data, which is not a good thing. So yeah, which is also a really good reason to not introduce power onto a machine until you know for sure what state the machine is in. So, like I said, before you introduce power to your machine, make sure you know what state the machine is in. Otherwise, you may be creating more harm to the machine in the process of trying to fix it. This is not usually that should be a thing to really be aware of if it's a low power, for example. But if it's an issue like no backlight, no display, so there is no harm in connecting your charger. You understand? Because the device is not in that stage where you could potentially do more harm to it than good. So if it's like a no backlight, no sound, no Wi-Fi, no, in that state, obviously. So what you can confirm that there is no active short, or there is no short on the board that may potentially escalate um, by connecting charger. So the whole point of not connecting charger is when you are not sure what state the device is in. For example, no power. You don't know why the device is in no power. If there's a short, or if there's this, or there's that. So before you confirm what state it is, you don't connect your charger. But if you are able to confirm it, somebody tell you, oh, uh, machine it's for example no power, no, not the no power, but for example no backlight, sound, touch bar not working, keyboard not working. I mean, all of those defined issues. So yeah, the board is out. The next thing we want to do is we want to flip the board to the other side to see what we have, to see if okay. So C9081 is definitely faulty. This is a cap here. I mean, it follows the same process as you guys can get to know by now. It's always on this other side that gets affected, and then obviously then it then creates a short. Now, the thing we want to do now is we want to remove C9081 from the rail, and let us hope that U9080, which is this, has not been affected. So let's hope that has not been affected, and one way to confirm that is to measure again. So now that the capacitor is out of the rail, the next thing we want to do is we want to measure again to see if we still have a short. Okay, so let's check again. Okay, that's good. So now our short is gone. So that basically also now the previous information will tell us that the batteries of this multimeter, they are getting weak. So yeah, that's good because now we no longer have a short. Now it is safe to obviously connect to charger. Now, so that was our problem. It was just C9081 as usual, and this obviously will fall under the common issues. Uh, but however, there is something else. Okay, there's something else. There's something else. So I'm just going to open up the schematic and show you guys something that I just saw now. So C90, this is the cap that was faulty. However, now we have R90 98. Now R1998, it's going to take 2.5 volt. So that is the enable signal, 2.5 volt, and then we have the enable signal. Now, the enable signal, so here, let's just do this. Let's change the view. Okay, go back. So now R90, R1998, let's go to the other side of the board. U9000, there's a communication between pin 5 of pin 45. Okay, let's open up the schematic. Let's go to U9000. You guys will have a better idea what this is about. You put your machine forward. Okay. Oh, yeah. I'll do that. Yeah. U9000.
Yeah.
Motions.
This is the one, I think it is one where that I work on it. But the network doesn't,
11-inch.
yeah.
What is
The network it works, but it's still like very, very low. Doesn't go
check
up.
with our network? So power it on and hold the Alt key and see if hold the Alt key. Yeah, and see what network you pick up from there. So Peter would. So pin 45. Let's go to pin 45. There's our pin 45 here. So here, so it's gonna be here SSD underscore voltage VR underscore P 2.5 volt underscore EN. Now, the reason why that is important is because here, I'll show you guys something. There's supposed to be communication between pin 45 of U9000 and and um, R1998. So because R1998 is then going, because of the pin 2 of R1998, which is going to be 2.5 volt EN, which is the enable signal. Yeah, and then that goes to, now that then goes to U9080. So that's the enable signal. So if you check U9080, just gonna do U9080. So you see the enable signal of U9080, which is gonna come from, so here, this enable signal, it's gonna come from that resistor. Now that resistor, uh, did you find? Yeah. Now click on that. Just yes. Use the arrow key. Arrow key. Yeah. No network. Did you try another card?
Yeah, this is we put a card in. We took it from the other machine.
Right.
The
And it's
card
still the
is
same
working
thing.
perfect.
Okay, I'll check it out for you. So, so here, this enable signal, U9080, it's going to come from, no, that's a resistor. However, that is enabled by U9000 through SSD underscore VR underscore. So this is now going to go through that resistor and then come to U9080. So my concern now is there is a pad. If you look at now between the pin 1 of R9080, there is a pad here. This is a pad that this is basically a link between R9080 and U9000. So when this pad is broken, what's going to happen is there will be no communication between R9080 and U9000, which means the signal when it comes is just going to stop here and will not get it. And if it doesn't get it, it means there will be no output from. So what I don't know if you get what I'm trying to say. So so the reason why I'm concerned with that is because of this. You see that? It looks as if the signal is broken. So we're just going to scratch it off and confirm if that is the case. Let's get something to scratch it off to see if that's, because if the signal is broken off, then let's see. Looks like the download it's complete. is installing now. Downloading our DFU. Let's accept. Okay, let's go back to that. So now let's try to scratch that. See if we have a pad. Okay, the pad is fine. We don't have a problem with the pad. I can see an active pad. And another way we can definitely confirm that the pad is fine is to see if we have 2.5 volt on the other side of the resistor. Because if we don't have 2.5 volt on the other side of the resistor, it simply means that there's a broken communication. But now the pad is fine, so we can see that the pad is fine. So my concern was that pad, because if that pad is broken, what's going to happen is the machine obviously will not start. So you will get the trackpad, you will get a feedback on your trackpad, but that's about it. The machine is not going to start because your NAND is not being powered basically. So one of the way we can confirm that indeed that is working is to see if we have 2.5 volt. uh, so we can see if we have 2.5 volt here. See if we have 2.5 volt. And those, let's connect charger. What happened to my, uh, where are my charging ports?
So check on those cards.
Where?
On those
Here.
Wi-Fi cards.
Okay. Is it still installing? Okay, still installing. Now we need, please help me with the cable, USB-C cable. Thank you. And you can have this back. Thank you. Thank you. So one of the ways we can confirm that indeed, so first and first, we had a short on our PPBUS. So now let's see what we have on our PPBUS. So 12.6 will tell us that that the machine is starting. 12.3 will tell us that the machine is not starting. So let's see what we have on our PPBUS, if it's 12.6 or 12.3. Okay, 12.6, that tells us that the machine is starting. Now let's see what we have on our NAND output. See if we have 2.5 or less than that. 2.5, so that means our resistor is fine, and our NAND is getting what it should get, which is 2.5. So that is fine. So the next thing we want to do is we want to dust the board and test our board. But at this stage, we can actually, I mean, this looks all good because 2.5, that's the voltage that um, we were expecting to get, and then we have a starting voltage on the PPBUS rail, which is good. So now what we want to do is we want to put the board in the shell and see what we get. Expecting to have so whenever you're working on this device, it's very good that you at least try to clean it up, not just, and then while you're doing this, be very careful with the touch ID. It's a tiny cable, and somehow you may break it in the process. So be very aware of it. You don't want to break it. And I mean, if somebody came for something, the device, it's a low power. There is no reason why the touch ID should be broken. So be aware. For example, when I do this, chances of me breaking it is high. But when I do this, then I'm not going against it. I'm basically following the flow. But even if you do this, just be aware of it. It's important. It's one of the cables that once it breaks, because it's paired to the board, you now sit with the function of the touch ID function no longer being present, and that is, it's not a good thing, because yeah, and then now the client will now have to sit with with a board without the Touch ID, unless it gets paired again by Apple, and for some reason Apple obviously they refuse to release
You
the
see,
data
even
flow.
though people don't use it, but the moment you know that it's not working and they're making
Yeah,
the issue,
it's a human nature. It just works on your nerves, you know.
they don't
It's
use it,
like
but the moment you say, "Oh, this,"
yeah, it's just like you know when people go for checkup, yeah, and then they tell them you have cancer, for example, or they tell them you have a particular problem. Before that time, they were the same persons and they were just fine.
they're
But
fine, yeah.
immediately you tell them that hey, this is your problem. No, it changes
It
your
changes, and then we
whole
get, sometimes like you don't tell people, sometimes like you don't just need not to tell them until they find out.
yeah.
Because the moment you
No,
tell
no, no,
him,
but
he's gonna draw
it is
attention
your
on
duty.
that
It is your
particular thing.
duty as a
Okay, this,
technician. You must inform them.
yeah, I mean, it's very good,
You
but
must
this,
inform them. You cannot not inform them because
but sometimes you see that this is gonna raise like so many issues because the person doesn't really need it, but the moment you mention it,
and but
the
regardless of
whole
what issue,
attention you know draw on that particular thing.
regardless of what issue it raises, they must
Mm.
be aware. You tell them, okay, this is what has happened,
Mm.
and then it gets dealt with there and there. But they must be aware. You cannot, they cannot be the one to come back and say, oh, by the way, I found that this. No, no, they must be aware.
Mm.
Okay, we just put one or two screws to
Not bad.
hold
Somebody put one there.
the board in
The moment
place.
you tell them and they say, ah, this one is going to be a really fine.
Okay, so now let's test our machine. Hope it works. Now we can connect our charger. We have trackpad feedback. It's a good sign.
There you go.
And that's it. That's a successful repair. And then this is gonna go to a happy client. So yeah, I don't want you guys to see that. So that is yeah, so you guys can see the devices. And then something else I was telling somebody about the touch bar. So you can see that the touch bar is not active. Yeah. So this is it is because we are coming from a cold boot. So code boot. So depending on the depending on the firmware of the firmware you have on your T2, depending on the firmware that you have, that will determine if when you come out from a cold boot, you will have the touch bar being active or only after you log in.
After you log in,
You
yeah.
understand? So however, when you log in, the touch bar is going to become active. Yeah.
Okay, I see
Now,
what
when
you're
it's
saying.
active now, and then when you're restarting the second time, that is referred to as a warm boot, not a cold boot.
Okay.
You understand?
Yeah,
Then when you come from the second time, you will find the
so
touch bar.
touch
Yeah,
bar
but because yeah,
before
do you
even you
understand?
log in, you put the password.
Exactly.
In.
So in case you're working on a device like this, and then you be like, oh, why is my touch bar not on? It's because of you are coming from a code boot, and also depending on what firmware that you're running, determine. So yeah, just in case. And then sometimes it may be a problem, and then a client will be like, you'll be like, oh no, I tested it, it was working. No, you lied. How did you find it working? Because it wouldn't. It's the fact that you took the board out, there was power coming out of the board, so it's gonna come from a cold boot. This is a device that was not working. It was a no power. So that's something just to be aware of. When your device comes from a cold boot, the touch bar will not be active until you put in your password, and then the touch bar will be active. And then so with the touch bar and the touch bar and the touch ID will be controlled. For example, like so this has a T2, like the T1 for example, the T1 would control the touch bar. So it's a T1. So the T1 was
This one is 17.
yeah. So this will have a T1. So this is your T1 chip, for example. So that is your T1 chip. So that is what is going to basically control. So now the touch bar will use what is known as the bridge OS. That's what. So the touch bar has a separate operating system on its own.
Oh, really?
Yeah. So that is what is known as the bridge OS. So
Oh,
it's
it
not a
doesn't.
it's not a it's not a it's not it's not a it's not a full operating system, just like but it's referred to as a bridge OS. So that's a tube. So it's controlled, which is also why sometimes, say for example, if you have issues with your touch bar, the machine may not boot. The machine will not boot. You get a critical update issue. Yeah, that's one of the things. So yeah, that is that about that. Uh, the file of this seem to be okay. Let's just do a program reset. Okay, that's pretty much it. This can now get finalized, and yeah. So, and then another thing to take note of, you see that the battery, yeah, it doesn't show you that it's connected. However, you see that it's increasing. That is also because you're not logged in. You understand? That's also something to take note of. You understand? Because sometimes also when, especially when the client is here and then they tell you, oh, but I don't see the charge inside. So that is because the device is not logged in, and also that also works because that also would work with the same fact that you are on cold boot, not warm boot. You understand? So the cold boot process will only be complete after the log in. Until you log in, you're still on the process of cold boot.
Yeah.
You understand? Once you log in, then the boot is complete. Now, when you restart, that's a warm boot. You understand? So you're already logged in. That's just that, guys, and that's gonna be the end of our repair. See you guys in the next one. Thank you.